By the time you reach the end of the Java mastery path, the goal isn't just writing correct code, it's building something you could actually ship. This capstone puts every level 4 pattern into one real service, a Spring Boot order management API, with validation, tests, Docker, and CI. Let's build it stage by stage. Stage 1 is the domain model, what an order actually is, and what's allowed to cross the wire. Here's the whole project shape before we write a line of logic. A model package holds the entity and its status enum, DTO holds what crosses the wire, repository talks to the database, service holds business rules, controller exposes HTTP endpoints, and exception centralizes error handling. Tests mirror that same package structure. Status starts simple, an order is pending, confirmed, or cancelled. Keeping this as a plain enum instead of a raw string means the compiler catches typos, and every transition rule lives in one place. The order entity is a JPA entity mapped to an orders table. Customer email can't be blank, total must be positive, and status is stored as a string enum, not an ordinal, so the database stays readable. Notice there's no public noargs constructor. JPA gets a protected one, and every real order is built through the constructor that sets status to pending and stamps created at automatically. Confirm and cancel are the only ways to change an order's status, and they live on the entity itself, not the service. Each one checks the current status before allowing the change, and throws a plain illegal state exception if the transition doesn't make sense, confirming a cancelled order, for instance. That's the entity protecting its own rules regardless of who's calling it. Notice the entity never leaves the service layer directly. Create order request is a record with bean validation annotations. A blank email or a non-positive total gets rejected before your code even runs. Order response is what actually goes back to the client, built with a static from method that maps the entity's fields across. With the shape of an order and its transport format defined, we're ready to build the layer that actually manipulates it, the repository and the service. Stage 2 is the service layer where the data access and the business rules live. Order repository extends Spring Data's JPA repository, so create, find by ID, and find all come for free. The only code we write ourselves is two derived query methods: find orders by customer email, and find orders by status, and Spring generates the SQL from the method names. The service constructor takes order repository plain constructor injection, no field auto-wiring. Create builds a new order, saves it, and logs the result. Find by ID either returns the order or throws a custom order not found exception, and every other method that needs an order reuses that same find by ID, so the not found handling only exists once. Confirm and cancel follow the same pattern: load the order, ask the entity to change its own state, and catch the illegal state exception it throws if the transition isn't legal. The service translates that into an invalid order state exception. The entity protects its own invariants, and the service decides what that means for the API. With the right path and its rules in place, it's time to expose it over HTTP. Stage 3 puts that logic behind a real REST API. Order controller is thin on purpose: 5 endpoints, each just a few lines. Post/orders takes an valid at request body, so an invalid create order request never even reaches the service. Spring rejects it first. Get by ID and get the full list return order response, not the entity, keeping that DTO boundary from stage 1. The two confirm and cancel endpoints are just post mappings on a subpath, delegating straight to the service methods we just wrote. Every one of these can throw a missing order, an invalid transition, and none of them catch anything themselves, because error handling lives in exactly one place, which is where we're headed next. Stage 4 centralizes every error into one place. Both custom exceptions are deliberately minimal plain runtime exceptions with a constructor that builds a clear message. Order not found exception takes the ID that wasn't found, invalid order state exception just takes whatever message the entity produced. Neither class does anything else, because the real handling logic lives somewhere else entirely. Global Exception Handler is a at-rest controller advice, so it applies across every controller in the app, not just this one. It maps order not found exception to a 404, invalid order state exception to a 409 conflict, and Spring's own method argument not valid exception the one bean validation throws to a 400, with all the field errors joined into one readable message. Every branch returns the same shape, a timestamp and a message, so API consumers always know what to expect from a failure. With input validated and errors handled consistently, the only thing left to prove is that it actually works. Stage 5 proves it actually works, at 2 different levels. Order service test never touches a real database. At extend with Mockito extension and at mock give it a fake order repository, and at inject mocks wires that fake into the real order service. The first test stub saved to just return whatever it was given, then checks the service actually built the order correctly. The second proves find by ID throws order not found exception when the repository comes back empty. The exact behavior global exception handler depends on downstream. Order controller IT is a different kind of test entirely. At Spring Boot test boots the real application context, and at auto-configure MockMvc lets it fire real HTTP requests without a real server. Test property source swaps Postgres for an in-memory H2 database in PostgreSQL compatibility mode, so this test is fast and needs nothing installed. The first test posts a valid order and checks the full JSON response, the second posts a bad email and a negative total, and just checks that it comes back as a 400 proving validation and the exception handler actually work together end-to-end. Unit tests and integration tests each caught something the other couldn't, which is exactly the point of writing both. Now let's ship it. Stage 6 packages the whole thing into a container. The Dockerfile is multi-stage on purpose. Stage 1 uses the full Maven image to download dependencies and compile the jar that stage never ships. Stage 2 starts fresh from a small JRE-only Alpine image, copies just the built jar out of the first stage, and runs as a non-root app user instead of root. The final image doesn't contain Maven, the source code, or any build tooling, just a JRE and one jar file. docker-compose.yml wires 2 services together, the app, built from that Dockerfile, and a Postgres 16 container for it to talk to. The database password comes from an environment variable, never hard-coded, and a named volume keeps the data around between restarts. One command docker-compose up build brings up a working app and its database together, which is exactly what you'd want for local development or a quick demo. Stage 7 wires up continuous integration. The CI workflow runs on every push and pull request to main. The first job checks out the code, sets up JDK21 with Maven caching, and runs MVN test. If anything fails here, the workflow stops and nothing gets built. The second job only runs after tests pass, and only on an actual push, not a pull request, where it builds the Docker image tagged with the commit SHA. That ordering test first, build second, gated on success is the same shape you'll find in production CI pipelines everywhere. Once it's running, whether locally or in Docker, the same curl commands prove the whole thing works: post a new order, confirm it, list every order, and hit /actuator/health for the liveness check Spring Boot Actuator gives you for free. That last endpoint is what a load balancer or Kubernetes would pull to know the service is alive. One line in application.properties, and you get production-grade health reporting with zero code. That's the full Arc domain model: service layer, REST endpoints, centralized error handling, 2 levels of tests, a multi-stage Docker build, and a CI pipeline that gates the build on passing tests. It's the same shape you'll find in real production Java services, and it's where the whole Java mastery path comes together. The full write-up, with every file's code, is linked below.